This video corresponds to chapter 16 of this book, and in this video I'm gonna calculate a beam with a distributed load and check the results of that calculation with help of free FEM tool Autodesk Forceeffect. So here you have the example that I'm gonna calculate. I'm gonna calculate a profile of 1 meter long, and I'm gonna calculate the maximum moment that's inside this beam using a free online FEM tool. It's called Autodesk Forceeffect. It won't give you all the results that commercial FEM packages will give you, but it can give you a lot of helpful results already. So here you have the drawing of the beam with a virtual cut. So the beam has been cut here in the middle to get the value of the internal moment in the beam, and I've already done this calculation with the shear and moment diagrams over here. The maximum value is Q, the distributed load, times the length to the square divided by 8, and how this maximum value was calculated is written on the next page. So switch to the next page here. Here you see the whole calculation of how to calculate the maximum moment with help of a virtually cut beam. How to calculate the maximum moment when there is a distributed load, and you'll find that the maximum moment is the distributed load times the length to the square divided by 8, and here I have it filled out for this example of a beam of 1 meter long. I get a value of 100 times the length to the squared is 100 times 1,000 squared divided by 8, and I'll get this value, and I can reproduce that with help of the free FEM tool, as I'm going to do now. So I'm going to switch over. This is Autodesk Forceeffect. You can start it just by using this website. If you then log in, then you can also save your models. But if you don't log in, you can already start a calculation. So it's convenient to create a login, and then you can save your models, which is convenient. So I'll start a new diagram. I'll draw a beam of 1 meter length. So this is too long, but I can change that. So change that to 1 meter, 1000 millimeter, like that. I'm gonna apply my fixtures over here and a sliding fixture over here, and then create a force. I want a distributed load, and I can do that by clicking over here and then dragging the load like that. Autodesk Forceeffect will already give me some visual results immediately, and now I had a value of 100 Newton per millimeter that I used in the previous slide. Let me see, I can move the diagram a little. So 100 Newton per millimeter. Autodesk Forceeffect immediately recalculates that in a total force, and now I can use the report to get the shear and moment diagrams for this beam. So just push here report, and now here I get a nice report, and here I see the shear diagram, and here I see the moment diagram, and the maximum value is indeed as previously calculated. It is 1.25 E7. If you put the dot here, you'll find you'll have 7 characters behind the dot. So 1.25 E7 Newton multiplied by millimeter. So never divided by millimeter, it's Newton multiplied by millimeter. And it's exactly the value that I have over here. So 1.25 E7 Newton times millimeter is 1.25 E4 Newton over a meter. So it's you have to see that to be able to switch these two values into each other. So this force working over a millimeter is the same moment as this force working over a complete meter. So now I've used a free online tool, Autodesk Forceeffect, to get the shear and moment diagrams of this beam, which is convenient. Now, if you were to have a more commercial available FEM software package, you would also be able to analyze this profile and analyze the maximum deflection. That's not yet possible with Autodesk Forceeffect, maybe in the future, but At this moment it's not yet possible, but you can use Autodesk Forceeffect to verify your results, which is always better than not verifying anything at all. So that was the presentation on Autodesk Forceeffect and how to use it. I've showed a convenient way of generating a report and checking the results. So thanks for watching.